Exercise 7C, combinations of transformations. So now we need to work out what the new image of these equations when we've done both translations, dilations, and, well, I said both, maybe all three reflections as well. Again, it's what will be very useful is to do a systematic process, because often what happens is that the order of the transformations can affect what the final answer will be. Let's have a look. Example 7c.1. Find the equation of the image to the graph of y equals negative x squared when each of the following sequences of transformations have been applied. A translation of 2 units in the positive direction of the x-axis, followed by a dilation of factor 3 from the x-axis. Now, when I do these sorts of questions, I would set up my little XY arrow business. Now I would do a little systematic approach each time. So I'm going to start by running XY. We started with a translation of 2 units in the positive direction of the x-axis. So I'm going to write x plus 2, y, and then a dilation of factor 3 from the x-axis. So that's going to be, remember, from the x-axis is going to be dealing with the y values. So we're going to put a 3y here. And as with all the other examples, I'm going to write my transformation statement, and I'm going to rearrange the equation such that the original value is the subject. So the little x with the apostrophe will be the answer, and I'm going to get it rearranged into the original. Then I'm going to do a substitution. And then write my final equation. Y equals negative 3, brackets x minus 2 squared. B, a translation of 3 units in the negative direction of the x-axis, followed by a reflection in the x-axis. So first of all, set up your the sequence of events using the XY notation. Then write the transformation statements. And then substitute. And there's our final answer. Because remember, the original equation was a negative x squared, so therefore, by flipping it the other way around, we have a positive quadratic. A reflection in the x-axis followed by a dilation of factor of 3 from the x-axis. Now notice with this one, we've actually applied 2 transformations to the one letter. So we start with doing negative y, because that's a reflection in the x-axis. And then I had to times it by 3, because it's a dilation of factor from the x-axis. And so that's why it's negative 3y. In this instance, nothing's happened to the x values. So we're only going to have to write one transformation statement. And then we substitute. And there's our final answer. A reflection in the x-axis followed by a dilation of factor 2 from the y-axis. Let's start by setting up our systematic approach to these transformations using the XY notation. Sometimes what can happen is that if you feel a little confident, you sometimes can make a very easy mistake when it says from the y-axis or from the x-axis. Since it's a dilation of factor 2 from the y-axis, it's going to affect the x's. And now to write our transformation statements. And now for the substitution. And there's our final answer. Where did the 4 come from? Well, remember that I have to square everything. So x squared would live at the top. And little 2 in the denominator also gets squared, and thus it becomes 4. A dilation of factor 2 from the x-axis, followed by a translation of 2 units in the positive direction of the x-axis and 3 units in the negative direction of the y-axis. We've got a shopping list of transformations to do here, but again, a systematic approach will help us enormously. And there we have our systematic approach. Now, just as note here, we've got the dilation of factor 2 from the x-axis, followed by a dilation, followed by the translation in the y-axis and things like that. Please be aware if those instructions were a little bit different, and I'll get back to that in just a moment. This 2y minus 3 could look very different if it was given a very different set of transformations, and I'll show you what that just after we get this one done. So what I'm going to do here is I'm going to go and do my transformation statements, then our substitutions. Now, at this stage, I have made a mistake. And how did I know I've made a mistake? It says here in 3 units in the negative direction of the y-axis. And I notice my final answer has a positive. Where did I go wrong? Well, this is what I was telling you about being far too confident with all of your transformations. I got 2y minus 3. And when I was adding on both, I should have made that a plus up here. Should have made this a plus down here. Plus, and so this should have been a minus over here. So it's always worthwhile checking to make sure that you haven't gone and done a derp like Mr. Innes, and you've gone too fast with your transformation statements. So there's our final answer. So what I was talking about before is we've got this statement here, or this 2y forms 2y minus 3. What I wanted to say was, so we've got here, we've got dilation of factor 2 from the x-axis. We've got a translation x. And 3 units in the negative direction of the y-axis. What I'm going to suggest, I'm just going to tell you what would it look like, how different it might look if this statement here, that I'm just circling here, if this was put at the start. Okay. So if that was at the start, what you would get would be you'd get 3 units in the negative direction of the y-axis, then a dilation of factor 2 from the x-axis, and what that would do is that would multiply everything. So that's going to become 2y minus 3, like so. And then we've got translation of 2 units in the positive direction of the x-axis, and then it would look something like this. So the order is very important, because if I dilate at this point, at that 2 brackets y minus 3, if I had dilated at that point, then the actual translation that occurs would be 6 rather than 3. So just be aware that that's something that can that is an example of how these dilations and translations can be affected. A dilation of factor 2 from the y-axis, followed by a translation of 2 units in the negative direction of the x-axis, and 3 units in the negative direction of the y-axis. Let's get our systematic approach with our xy notation. And now let's do our transformation statements and then our substitutions. And there's our final equation. As a fun note, please don't bother expanding that bracket at the top. It's perfectly happy being factorized like so, and it's actually the simplest way to be able to express it. So just leave it as is. And again, that 4 at the bottom comes from the fact that the 2 in the denominator from the substitution has to also get squared.